Alright, mateys, we're going to learn about trigonometry. Hello, everyone. We're going to tackle some trigonometry today. Alright? It sounds like a very big word, and a lot of kids get frightened by it, but I'm going to try to teach it. It's a very simple concept once we get into the triangles. Okay, so by the end of this video, you're going to be able to estimate or approximate what the value of the trig function is using a calculator and by hand, and also find the ratio of the trig function. And that's all we're going to do today. We're going to apply it later. So the first thing I want you to think of is a circle. Trig is all dependent on the unit circle. And I'm going to use this sword here to demonstrate. This sword is going to be 1 unit. Okay? And we're just going to rotate this all the way around the circle. That's going to be my radius. So trig uses ratios based off this 1 unit. This 1 unit could be the sword. It could be this wand if I wanted to. It could be my finger. But as long as I have 1 unit, I can kind of approximate the trig value. So the first thing I'm going to do is I'm going to draw in my radius. So I'm going to start, okay? That is approximately 1 sword length, okay? Now, as I rotate my sword around the circle, this circle moves along the circumference. And if I stop it here, I'm just going to make a point. Now what I did was I created an angle. Okay? And that angle is going to be called theta. Okay? It's a Greek letter. We use it for angles all the time. It's just an O with a line through it. Sometimes you'll see people do that. It just stands for angle. Now, trig values are represented by the length here and the length here. Okay? So, if this is 1 unit long, okay, in this case, a sword, we define this as the cosine of the angle. Okay, it's COS. You'll find that button on the calculator. It's pronounced the cosine. Okay, the vertical line or the height is what we call the sine of that angle. Okay, and that's S-I-N-E. Okay, that's the sine of the angle. So how far horizontally, how far vertically along the unit circle is what we call the trig functions. Now, there's 3 basic trig functions. There's the sine function, there's the cosine function, and then they also use the tangent function. The tangent function of any angle, or tangent, means that it's the slope of this line, okay? So we want to think of it as the slope of the line. And that slope is found by rise over run. So it's the sine over the cosine. Now there's an easier ratio later that I'm going to talk about, but this is where trig functions were developed. Based off the unit circle and using the horizontal distance and the vertical distance to get the sine and the cosine. Now before calculators, we had to approximate trig functions. So in these examples, okay, they say, all right, what is the sine of 10 degrees? Well, you can plug it into your calculator and you can get a huge long decimal. I can't do that. I don't have a calculator. All I have is my radius. So what I'm going to do is I'm going to draw my radius. Boom. Make it a little long. Now I'm going to rotate it about 10 degrees. Okay, I think 10 degrees is right about there. I'm going to make a point. Okay. Now, I'm asking for the sine. So the sine is actually the vertical distance, straight back down. I need to make a 90-degree angle there. So now, if I look at my unit, okay, it's not the whole line. Okay, I'll actually put it down here. I would say it's about a fifth of it, or about like 0.2 of this whole sword. Okay, so this is approximately 0.2, and that's how they used to do it. Is they had to move this radius, and then they had to find the ratio for the height moved up to the actual unit that they were using. Now, if you plug it into your calculator, you can actually approximate this. Again, your calculator runs it out to a whole lot of decimal places, to about 0.1736. Now, we can also do the same thing with the cosine. The cosine, again, I'm going to draw my radius. Okay, as best as possible. Now, I'm going to go up 38 degrees. So the cosine of 38 degrees. Okay, so I'm going to end it. I'm going to move it up, I would say about there for 30 degrees. Okay, I'm going to make a point right at the end of my sword. I'm going to drop it down. Okay, now cosine is the horizontal distance. The horizontal distance, okay, let's see how that matched up. Oh, well, it didn't make it all the way to the end of the sword, but it went pretty far on it. So, about 0.8 away. So, I would say that's approximately 0.8. Now, if you plug that into your calculator, actually, you get it to be approximately 0.788. And you can also do the same thing with the trig function, or the tangent function. So the tangent of 45. So again, I'm going to start with my radius. Okay. Imagine that's a straight line. I'm going to move this up 44 degrees. About there, right? Okay. I'm going to drop this distance down. Okay, let's look at that. Remember, the tangent of 44 is actually the sine over the cosine. Well, that is the vertical distance over the horizontal distance. So let's look at that. Okay. This distance, vertically, divided by that distance, horizontally, they're about equal. So, I would say about 0.7 over, that was a little bit longer in there, 0.75, and I can actually do that division, but it should be kind of close to 1. And if you think of the slope of the line, it's about a slope of 1. And you can plug that into your calculator and find it. And that's how you approximate trig functions. So you understand, all right, did I get the right answer or did I not? But in reality, We don't really use the unit circle a lot. We do it with a triangle. So let me draw this again. Okay. Again, we call this the radius, and we call this the cosine. And this is the sine of that angle. Now, if I translate that over here, this is a right triangle. Now, we all know the opposite side to the right triangle is called the hypotenuse. Okay, let's define this as my theta, my angle that I'm looking at. Well, I'm really looking at, okay, this right here is my cosine. And this right here is my sine. But is my hypotenuse always 1? It's not always 1. But using similar triangles, I know that even if this radius grows to twice as long, okay, I add a radius and then a radius, then this cosine value, all it does is it doubles. And this doubles. If this is 2 radiuses long. If it's 3, it doubles. It's 4, it doubles. Or it keeps going on and on. So really, if I can take any length of this, and if I multiply it by the cosine, I can find that value. I can multiply my hypotenuse by my sine and get that value for this angle and this triangle. And I can find this height here. And it's all based off that hypotenuse, that one unit that I have. Now, most of the time, we don't relate it like that. We say, okay, this sine right here, this cosine side, it's next to that angle. It's the adjacent side. The sine is the opposite side. Because it's way far away from that angle. This one's next to, adjacent meaning next to, opposite is on the other side. So we can actually set up an equation. Okay? H sine of theta of that angle equals that opposite side. Well, we don't usually relate it like that. We usually say sine theta. Oh, well, h is multiplying, so I'm just going to divide by h on this side. And I get my trig value that you'll hear all the time. The sine of any angle in a right triangle is equal to the opposite side divided by the hypotenuse. I can repeat the process with the cosine. The cosine equals that length of that adjacent side. Now if I divide by h, I get the cosine of theta equals the adjacent side over the hypotenuse. And the tangent function can actually be found of any angle. Can be found by taking the opposite side and dividing by the adjacent side. So we're going to use that to find some lengths of triangles. Right now we're just going to practice setting up those ratios. So in this case, I have a generic triangle just labeled R, S, and T. T having to be the hypotenuse. Okay? And what we ask for is the sine of R. So what we ask for is the leg opposite R. So R is over here. So I look across from R, and I see a little R. So I'm going to put that on top. The hypotenuse being T. The cosine of R, the leg adjacent to R. Adjacent meaning right next to. And that is S. Over the hypotenuse, which is T. And then the tangent is the leg opposite R, lowercase, and the leg adjacent S. All I do is I make those fractions, and I can reduce if I have a calculator and some numbers. So in this case, in this example, the sine, you're asked, okay, what's the sine, cosine, and tangent of angle A? And you're given lengths. So what we're going to do, we have to figure out what's the leg opposite A. Well, I'm going to mark A. I'm going to draw an arrow. That is 5. What's the hypotenuse of that triangle? 13. Okay, what's the cosine of A? Cosine of A, the adjacent side, the one next to that angle, 12. Hypotenuse always stays at 13. Tangent of A, opposite side, 5. Adjacent side, 12. So what happens is we set up these ratios. We can also reduce them down by dividing in our calculator. What we do is just 5 divided by 13, that comes out to be that 0.3846 approximately. 12 divided by 13, it's really close to 1. It's 0.923. And the tangent of A is 0.4167. Now, that is not the only angle that we can use. We can actually do the same thing for B. I know you're not asked for it in this, but if I locate B there, the sine of B on the top, we got to take the opposite side, 12, and divide by 13. Because the hypotenuse didn't change, so just the opposite or the adjacent changed, depending on which angle I look at. 12 divided by 13, we already did that one, that's 0.923. The cosine of B is that side adjacent, touching B, 5 over 13, the hypotenuse, 0.3846. And the tangent of B, now I do opposite over adjacent. In this case, it's 12 over 5, which when I reduce down to is 2.4. That's all you're doing tonight, setting up those ratios, dividing if you have the numbers, or plugging something into your calculator. That will get you ready to solve right triangles and to move on to trigonometry. Remember, fractions and proportions, that's all we're doing this unit. And I know right now that you are as interested as Mr. Burtis in this lesson right now. So, please complete this and come in with any questions next class.